Tricia Aung is a professor at Johns Hopkins University. She's interested in applications of human-centered design to improve health interventions and data used in low, middle-income industries. This includes optimizing access to essential medicines, data collection, and data visualization for decision making. She has experience applying user-centered design methods to global health and public health contexts, including user research, personas, prototyping, and usability research. Tricia has worked in global health for over 10 years after receiving her Master of Science in Public Health in International Health or Health Systems from Johns Hopkins School of Public Health. As a research associate, she focused on improving measurement of nutrition interventions and has supported evaluations of global health programs and policies. She pioneered in research in the global health data visualization literacy and preferences in LMICs. She has trained over 400 individuals on visualizing global health and nutrition data for decision making and provides technical support to global health stakeholders wanting to design data visualization accountability tools. She's currently a PhD student in the Department of Human-Centered Design and Engineering at University of Washington. Welcome, Tricia. The floor is yours.
Thank you so much. Can you hear me?
Loud and clear.
Oh, wonderful. So I'm going to share my screen. Can you see my slides?
Yes, we can see your slides.
Is it the entire view? Okay.
Yes.
Okay, wonderful. I'm so excited to be with you today, and thank you for the really kind introduction. My name is Tricia Aung, and I'm a research associate at Johns Hopkins School of Public Health. And I've worked in data visualization focusing on East and West Africa for the past 5 or 6 years. So happy International Women's Day. So what I'd like to highlight during this session is how we can use data visualization to strategically have people understand the data that we have. There's a wonderful book called Invisible Women, which is it talks about how women are underrepresented both in the data science field in terms of the actual data that is used for decision making. And I think it's really important not just that we collect the relevant data, but also that we ensure that the data is visualized in a way to emphasize key messages that we want individuals to remember. So in terms of how I got started in data visualization, I was working on a project called the National Evaluation Platform, the NEP. And Tanzania was one of the sites for NEP. And the thinking behind NEP is, why don't we help create some type of help desk, essentially, where we could help senior high-level policymakers with their burning, pressing policy questions. And so as the Hopkins NEP team would help a team of individuals answer those policy-making questions that were all related to maternal, newborn, and child health. We had an external evaluator come in, and they essentially said, you do really good work, but there isn't a lot of evidence that the data and your findings are influencing policy. And this was the finding in all of the NEP countries midway through the project. And so that inspired us to take stock and reflect on how we could better think about communicating the data that were part of our analysis in terms of facilitating policy making. So in terms of goals of this session, since we don't have very much time together, I'm going to go through a high-level overview of some things to keep in mind in terms of your data visualization choices, and also how we can incorporate user experience research in designing better data visualizations. So user experience research, and just to put this in perspective for you, is thinking about how we can reduce the frustration of individuals that are using a product. And so traditionally, this is thought of as something that is done when trying to build a website or to build an app and testing this with individuals. But the same concept can be applied to being able to visualize data in a way that resonates with people and encourages people to want to take action. So this is a quick overview of what is data visualization. It's the process of using graphics to tell a story. And why this is important is that our human brains can process pictures faster than text. So if you think about seeing a presentation and seeing just a table compared to actual illustrations. And then another thing to keep in mind with data visualizations is they can be data rich and information poor, which is kind of funny to think, because if a data visualization, if its whole purpose is to convey data, there is a risk of doing it in a way that may confuse an audience or may overload an audience with information. And so the audience doesn't really know what to get out of it. And so a lot of what I will be sharing today is based on data visualization research that has been conducted. Data visualization research tends to be led by computer science and cognitive science psychology departments on how you can better visualize data or new ways to visualize data. But one thing I want you to keep in mind while we're going through this research, and I'm sharing you different practices, is there has been almost no data visualization research that has been conducted in a population in Africa or in Asia in any type of low middle income country setting. And so the first known study that we did related to data visualization in any low middle income country was in Tanzania in partnership with Dr. Chua's team at the National Bureau of Statistics. Since then, we have also done a study in Nigeria on how to better optimize visualizing nutrition data. But I just want you to keep in mind that the space is very limited in terms of our evidence on what types of data visualization might resonate more for different types of audiences that might be in low middle income country settings and also in low data literacy settings. And it's a big need that I hope that everyone here is as passionate and will fill it. So one quote that I really enjoy related to data visualization is the graphic is only as useful as the audience finds it. Through the Data Visualization Society, which is a community practice of individuals who work in data visualization, I had led this discussion on how might we optimize visualizing data for low and middle income country audiences. And so one individual shared this comment, which I thought was really neat and kind of encapsulates a lot of the issues that can come up when visualizing data in different settings. For example, infrastructure. Thinking about how people consume data in different settings and where your target audience is located. A relevant example I was thinking of in terms of phone ownership. In some countries, in low middle income countries, partners, so a husband will share their mobile device with their spouse. And so thinking about how we, if we are designing data graphics or data visualizations that we want to reach mothers, first of all, they should be, accessible through the devices that these women have access to. Another infrastructure consideration, projector quality can be quite variable in many different countries. So thinking about what colors provide enough contrast that they would show up or they would be able to be printed in both settings where printing quality and projection quality can be quite variable is another consideration to think about how an audience would find a data visualization useful. An audience will not find it useful until they can see it. And so even the infrastructure, the rudimentary infrastructure consideration of will the graph show up on a projector screen is something that you should think about when analyzing and visualizing data. So in terms of the first exercise, I am going to show you one part of the study that that we conducted with the National Bureau of Statistics in Tanzania on how we could optimize the data visualization of our maternal newborn child health and nutrition findings for policymakers in Tanzania. And so the objective of the study was to characterize data visualization, interpretation capacity, and preferences among Tanzania stakeholders. So this is the exact exercise from the study where we showed individuals in the study different versions to visualize the same data. So I'm going to pause right here. And if you're joining online and if you're in person, well, if you're joining online, you can share your thoughts in the Zoom chat. And if you are joining in person, you can speak to the person next to you and how you would rank these data visualizations in terms of the key message identified. So in this scenario, we wanted to communicate the key message. During the past 15 years, a majority of under 5 deaths in mainland Tanzania have been attributable to the same 5 causes: neonatal measles, pneumonia, malaria, and diarrhea. Between 1999 and 2015, the proportion of under 5 deaths attributable to AIDS has decreased, while the proportion of under 5 deaths attributable to injuries has increased. So that is our key message. We have 3 different ways to visualize the data, same data set. And so if you're online again, or if you're in person, we can do this exercise together and rank the graphs based on which ones you think best represent the key message. So why don't we rank them in terms of the best? So which graph would you think is the best, and then the worst? So in the interest of time, I'm going to pause here. It looks like there are some brave individuals that are sharing their opinions on Zoom chat. Is there anyone in person who would like to share their views on which graph they think is the best? Alternatively, an individual online, feel free to unmute and be able to share, you're welcome to share your case. So it looks like online that most individuals are choosing the bar graph. So I believe that's option 2. Just a note in terms of the study that we conducted in Tanzania, when we are working with the National Bureau of Statistics on the study, individuals commented that I'm not sure if we should do this study because everyone's always going to choose the bar graph no matter what. Among the people that we work, people only want to use a bar graph and nothing else. And in terms of that comment, we discussed how, even having evidence that people choose bar graphs over the other graphs is quite important, particularly in the global health context that we work in, since individuals are visualizing data in different ways that extend beyond bar graphs. So I'm going to move on to the second example. So this is another interactive audience feedback example where if one key message, percentage of women with a birth in the last 5 years who took no iron tablets or syrup varies by household wealth in Nigeria. The difference among the poorest and richest decreased between 2008 and 2018. And so if you think the first one, the one on the left is better, you can share number 1. If you think the option on the right is better, you can share number 2. it looks like on Zoom right now, the individuals are quite split in terms of 1 and 2. So the graph on the left is a bar graph. The graph on the right is a connected dot plot. And so we'll revisit these examples and see maybe your opinions have changed. And I do want to emphasize that there really aren't terribly wrong answers when it comes to data visualization. There are different techniques. I think it all depends on what your audience needs. However, and there could be strategies that are a little more misguided, I think, than other strategies, but really there isn't a need to be scared of having the wrong answer. So how do we select appropriate data visualizations? So there's 3 different key dimensions that I'd like you to think about. The first is audience and understandability. Thanks. So in terms of audience and understandability, some of the first set of questions you can ask yourself is, who am I trying to reach? Who am I trying to communicate to? And how familiar are they with both the data and the concepts that are being communicated? So it's not just a familiarity with the data set, because if you think about, there's data that is visualized all the time in the media that individuals maybe common colloquial to us when we think of iron folic acid supplementation, for example, that may be more unfamiliar to others. And this is something that we've been thinking about a lot also in our work, because of additional indicators and additional data that's being incorporated in some of the large household data surveys that we use. This is also important to think about what type of annotations might be helpful to include in a data visualization, because if you think about certain visualizations that I've showed you might be less familiar to you. And so there is a potential benefit of including annotations to help people understand how to read a specific type of graph. Another aspect to think about is, what do you want the audience to remember? Ideally, you would want an individual to remember everything that you're presenting them, but realistically, they aren't going to remember very much. And if you aim too high, if you want individuals to remember too much information, sometimes you might fall short in getting an individual to remember something because of information overload. So it's always important to think about, what key message do I want an individual to remember, or key messages. And so that's the takeaway of something that someone's going to remember based on a data visualization that you create. And finally, what type of output would be the most appropriate? And so think whether your data visualization might be printed in a brief or part of a projection, or if it needs to be mobile friendly. And why this is important is, there are strategies to create interactive data visualizations on a website, for example. But if individuals don't necessarily have access to internet, it could be, a clear barrier to being able to appreciate the data visualizations that you are developing. And one story that has come from my work, and I help a lot of individuals that create data visualization tools, and things like dashboards and scorecards to visualize global health data for varying audiences. One stakeholder asked me personally, like if I had used their dashboard, and what I had to say to them, unfortunately, is my internet access in Baltimore in the US isn't even fast enough to load your data visualization. And so if you're targeting policymakers that are in settings where internet is expensive and where internet speed can be slow, it's a big leap to think that an individual would be regularly wanting to use their website if there are such infrastructure issues. So this is laid out steps that I have of thinking about, who is your audience, what's your key message, and is it understandable? Frequently, I feel with data visualization, we think about data visualization as a checkbox exercise after the analysis is done. And basically individuals put it together in a bar chart or a pie chart, depending on proportion or estimates, and then we call it a day. And so I'm encouraging you to think about the infrastructure involved, the infrastructure around the data that you are trying to share in order to optimize someone being able to take action on it. So in terms of who is your audience, one fun thing that you can do is create a user persona. And so user personas is more of a human-centered design technique where you can organize different characteristics that might influence your choices. So if you think about, traditionally think about developing an app, what types of does the individual have access to a smartphone? What type of smartphone it is? These are all different things that can be incorporated in a persona. But in terms of data visualization, on the screen, I have an example of a persona that could be developed that may inform your data visualization choice. And it's an exercise that you can do for yourself when trying to decide how to visualize your work. So in this example, we highlighted an individual who is an advisor to someone in the Ministry of Health who has certain languages that he speaks, and he has advice to a smartphone and a laptop in terms of his devices. We also have listed what this individual's daily responsibilities are, which may be to quickly collate data for individuals that he works for. So he is the person who is directly responsible for collating data and collating data visualizations for more senior staff and writing speeches related to that. We've also outlined how familiar this individual might be with the data that that person is being exposed to. So in terms of global health, we can think of large household surveys like the DHS or DHIS2, the routine health information system, and also think about dimensions of, is this person familiar with the indicators that we want to visualize? And so in this case, we have something about about vitamin A. We also have a category of additional considerations. And so we've listed here that perhaps this individual has a limited experience in nutrition in general. He has a laptop that freezes periodically, and he relies on Excel to do all of his data work. And he also might be colorblind. Something to keep in mind overarching when you're thinking about data visualization and color choices is some colors palettes are more difficult to see if one is colorblind. And when you're in a presentation, an individual is not necessarily going to raise their hand and say, oh, I'm colorblind, I can't read your graph. And when we did the study in Tanzania, that was an interesting finding that came up with a lot of individuals that were part of the study were sharing with us that they were colorblind or their colleagues are colorblind. And so we want to ensure that our data visualizations are as colorblind friendly as possible. Second is, what is your key message? So as I mentioned, it's what you're trying to get across, and it's what you want people to remember. It's important to consider key messages, and potentially if you're giving a presentation or creating an infographic, to think about how all of your key messages and how they might be strung along into a story. There are some very general categories of key messages, and that can guide your decision on what data visualization might be the most appropriate one to choose. So here's a listing of some common key messages. So this is how numbers are the same or different. This is how one number compares to a total, how numbers change over time, or this is one number that I really want you to remember. Because we are short on time today, I'm going to breeze through these slides that show some guidance on what you would choose and why. However, I have included them so they can be referred to as later. For example, a bar chart, it's important to think about, it might be advantageous to restrict the number of categories that are visualized in a bar graph. This is because our brains can get quite overwhelmed when processing a bar graph with many groups and many columns per group. Bar charts, by and large, are widely requested when I work with policymakers in a global health context in developing countries. And so one thing we want to keep in mind is how do we balance what stakeholders might want, which is bar charts in this case, with what we think might be alternative versions. Another version of comparing two different numbers is a slope graph. And why data visualization research suggests that this would be an appropriate way of visualizing data is our brains are pretty good at judging slope and rate of change. And so if you show someone a graph, someone will immediately say this is improving or this is not improving or staying the same. And so that lies in our brains. Our brains are attuned to think about things increasing, decreasing. So this is an example of how a bar graph could be changed into a slope graph. Other potential strategies that I'd like to focus on in this particular presentation is a connected dot plot. So this was an example that was part of the exercise at the beginning of the presentation. And dot plots are used to emphasize gaps between numbers. Why this is our brains have a pretty accurate ability to interpret space on a common axis. And so because these dots are on a common axis, the line, we're looking at the length of the line between dots. These types of graphs have also been described as equiplots, where equa stands for equity. A type of connected dot plot is a dumbbell plot. It's named this way because of the weight. And so a dumbbell plot has two different categories. And so the example on the left is households with iodized salt in Senegal by residents, where each resident represents a dot. The example on the right is about overweight. Why I want to also include this as an example of a dumbbell plot is there are arrows that show directionality of things improving or decreasing. A lollipop plot is another type of connected dot plot, is an alternative to a bar graph. And you can imagine that this data could be also visualized as a bar graph very easily. And the picture on the left is the politician Jaffo in Tanzania seeing this exact graph on the right and seeing this graph of skilled health workers per 10,000 people. This was one particular graph that he focused on during the dissemination event for NEP that struck with him. So here is an example of, and this is relevant to today's presentation about phone ownership. And you can imagine how data on female and male phone ownership and the gender gap might be important to individuals that are designing apps. So this was in a recent study that was done on phone ownership and comparing health outcomes to the gap in smartphone ownership in 15 low middle income countries. So in this particular example, it's visualized as a bar graph and a line graph where each bar, so there's two colored bars, one represents male, one represents female. The gap is an additional layer of a line graph. And so you can imagine that this could be reworked as a dumbbell plot where there is a male and a female dot that represents those estimates. And then the gender gap is represented by the line that connects the dumbbell plot. So like the graphs on this chart, on this slide. In terms of other types of graphs and things that I wanted to flag for you, a back-to-back bar chart can be used to emphasize symmetry. And so this is because our brains are attuned to thinking about symmetry. One of the original criteria for a good fashion model is someone who has a very symmetrical face, and it's because our brains gravitate towards comparing left and right. And finally, maps can be used to visualize categories, as you know, but one thing to keep in mind, and some individuals push back on using maps, is that the proportion of color is based on the size of the geographic region for good reasons, because different regions are different sizes. And so some individuals feel that maps can be misleading because, for example, there might be a higher dominance of one color just because the size of that geographic region is larger. However, And alternatively, what people have explored, rather than using specific maps, is to use proportional bubble plots or proportional maps where there are circles that represent the estimates rather than the actual geographic region. In my experience, using the actual map and actual geographic boundaries has been more advantageous because policymakers, they know what their region looks like. And so you end up receiving more questions when you try and modify those boundaries based on visual cues to make sure that there's some type of equity based on geographic boundaries. There also is an advantage of using maps in terms of a policy-making sense because people are inherently competitive. And so individuals want to see how certain regions are doing compared to other regions, particularly neighboring regions or regions that are governed by a different political party. So the common strategy to visualize proportion is a pie chart. However, pie charts can be quite polarizing. When you have many slices within a pie chart, it can make the pie chart difficult to read. Why, according to research, why pie charts may be more challenging to read is because our brains have difficulties accurately gauging angles and also arc length. And so one thing to keep in mind is maybe it's possible to only consider types of graphs that only rely on a pie chart if there aren't other options that are necessary, or if your audience insists on only using a pie chart. So these are alternative examples in terms of a stacked bar chart and 100% stacked bar chart. So this would be most akin to a pie chart, given the 100% categories. And then another strategy could be a proportion plot, comparing estimates within two different categories. And then finally, in terms of different types of key messages you may want to share, you may want to highlight trends over time. And so traditionally, this has always been a lie graph and what you should use. If you're only looking at two pieces of time, a slope graph would be appropriate. And finally, an area chart incorporates both change over time and proportion. When one number is very important, sounds really funny, but in honest, sometimes we want our audience to remember one specific number. And so you can tell that story by highlighting a single number in a big font, by using icons, and also leveraging color. So this is a case study that I've created. And so it's from the Citizen newspaper. And so this is data from the Tanzania Demographic and Health Survey for 2015 and 2016. The Citizen news article highlights how basic vaccination coverage increases the household wealth from 65% among children from the poorest households to 83% among children from the wealthiest households. So focusing on that message that the Citizen wanted to relay, what types of graphs might be appropriate to visualize this data? Feel free to share in the chat or talk to your neighbor if you're in person. So some examples of graphs that you might have chosen include bar graphs, but also you might be able to use a connected dot plot where each dot represents an estimate for that particular wealth quintile. And then the length of the line between those estimates can emphasize the gap. Finally, is it understandable? And so one aspect that gets lost with data visualization frequently is individuals assume that an audience can understand the data visualization that they're receiving. And it's a common mistake that I see. Edward Tufte, who is an individual who is very famous in data visualization, he says you should never underestimate your audience, but I would argue that it's equally difficult if you overestimate your audience. And so I mentioned that in user experience research, we think of usable as something that it does not frustrate. And so applying this similarly, we would want someone to be able to read a data visualization and to be able to understand without getting frustrated of, I have no clue what's going on. So in terms of different strategies where you could pilot test your data visualization, which is something that we've done in our work, is there is a strategy called talk aloud. This is more of a human-centered design strategy where you show someone something and you ask them, can you talk me through this? What do you see? And you notice the patterns of what individuals are saying while they are engaging with what you're showing. So in this particular example of how we've used Talk Aloud, in a data visualization study that we've conducted in Nigeria, we have shown individuals a specific graph that had indicators, nutrition indicators that were new to everyone. And we wanted individuals to be able to interpret the graph and talk aloud as they're interpreting. One interesting thing that we noticed while using a talk aloud protocol was individuals were first almost always reading out the title of the graph and axes labels, and also the legend. And so in this case, we knew that it was very important to ensure that we could optimize both the title of the graph and make sure that the axes labels were appropriate, because it seemed like those were anchor points that people were using to be able to interpret the data visualization that we were given and something that was unfamiliar with them. You can also consider asking more specific probing questions, like what do you think is the key message from this graph I'm showing? What elements of the data visualization helps you understand, or what causes more confusion, and what would you change? So here's an example of being able to accommodate and take into respect that you shouldn't assume that an audience might be able to interpret something on their own. This is an example from The Economist magazine on tracking COVID deaths. And this is a guide of how one would read the graphs. This is another example from the New York Times where annotations show what each of the dots mean in this particular connected dot plot. Another strategy to think about is color. As I mentioned, there are many individuals that are colorblind that we don't actually know. We don't have good global estimates of colorblind prevalence. Red-green tends to be the most common. And so you should ensure that your color palette is colorblind friendly. There are some limitations, particularly if you're working for an organization or you're working with government stakeholders where they have a set color palette as either their country colors or as their organization colors. And so to get around that, you can try and incorporate patterns into your graphs so they would be more discernible for individuals that are colorblind. Finally, I wanted to relay about communicating uncertainty and statistical significance. Consider your audience and whether understanding and whether visualizing confidence intervals are really necessary to get your main point across and to get your key message across. Unfortunately, many individuals really struggle with understanding the concept of statistical significance. I am currently represent, academia, and this idea of not always visualizing confidence intervals was really disturbing to individuals that I've talked to. But really thinking in terms of, would an individual who is receiving that data visualization be more likely to engage with it if there was no confidence interval visualized, is something to consider. When doing the study in partnership with the National Bureau of Statistics in Tanzania, one high-level policymaker said that showing a data visualization is like pouring water in a sack, implying that it was a waste of time and that individuals don't have time to think about and interpret confidence intervals. If you must display confidence intervals and show statistical significance, you must be able to explain it. And so here are tips on how you might be able to explain it to an audience where data literacy might be variable. So there's a statistically high chance that the actual number falls within this range, or this did not happen by chance. So finally, I'm going to let us revisit the examples from the beginning. So here is the first example. And feel free to share in chat or in person if you feel like your option changed, or if you still feel really strongly about your original choice, why you think that original choice might be superior. So a lot of individuals frequently choose option 2 and 3, basically because they are bar graphs and pie charts, and individuals are quite comfortable being able to use bar charts and pie charts, the regular bar charts. What I wanted to highlight in terms of this particular problem is number 2 is an 100% stacked bar chart. So the 100% stacked bar chart shows proportion, and also why it is a bit of a superior choice to the pie chart in this case is because we can see we can compare the different chunks of color by looking up and down and left and right. Again, this is how our brains are tuned. We think about up and down, left and right, and we think about proportional angles. And so that's why some individuals and many individuals would argue that one is better. In terms of the other example with a bar chart and an equiplot, in this example, one reason I would choose the bar chart and why the bar chart is okay is that there is some variability among the estimates, and so it's actually not too difficult to interpret. The dots on the equiplot are a little bit small, and so they're a bit more challenging to read. However, the equiplot on the right, the connected dot plot, does show gaps easier than the bar chart. So finally, to conclude, and I know I'm out of time as well, is so currently I am on a project called DataDent, which is funded by the Bill and Melinda Gates Foundation. It's focused on optimizing the use of nutrition data for decision making. And on the DataDent website, there are tutorials that I've developed on using Tableau and Tableau Public. Tableau Public is the free version of Tableau. And so if you would like to get started using Tableau, feel free to use this as a resource with a guided tutorial on how to create some of the graphs that you saw today. If you have any other questions on how to make some of the graphs that were shown today, please feel free to reach out to me over email, and I can help you with your code if possible and help get you on the right track. So thank you so much.